drops straight down into a dark, alien abyss. To understand the physics of what happens next, we have to look at the numbers. Oceans cover over 70% of the Earth's surface and hold roughly 97% of all the water on the planet. Without that water, Earth reveals its true topography. Places like the Mariana Trench are suddenly exposed as dry, jagged canyons plunging so deep they make terrestrial mountain ranges look like speed bumps. Trillions of marine animals, from blue whales to microscopic plankton, hit the dry seafloor simultaneously. Global shipping networks, the arteries of modern trade, are instantly stranded in the dirt. The Earth sheds its protective blue shell and becomes a jagged, exposed rock hurtling through space. Right now, the sheer mass of the global ocean pushes down on the Earth's crust with crushing hydrostatic pressure, averaging 250 atmospheres at mean depths. Remove that weight, and the crust undergoes isostatic rebound. The rock violently snaps upward. This sudden decompression is a geologic nightmare. Without the ocean's pressure, the 65,000-kilometer mid-ocean ridge cracks open, erupting in a planetary-scale volcanic paroxysm. The shifting crust's stress reactivates dormant fault lines everywhere. Magnitude 9 earthquakes rip through the continental shelves, reducing coastal megacities to dust in minutes. You might expect the immediate threat of a waterless world to be thirst. Instead, the real danger is the sudden, catastrophic mechanical destabilization of the ground we stand on. Assuming you survive the earthquakes, the next crisis is thermodynamic. Water has an incredibly high specific heat capacity, meaning it absorbs vast amounts of solar energy with very little change in temperature. This chart shows the ocean's heat content anomaly. The ocean has relentlessly absorbed over 90% of our excess heat. Without the ocean, this heat enters the atmosphere. Notice the steep red curve projected toward 2100. That energy would immediately cook the surface. The global conveyor belt of ocean currents, the thermohaline circulation, shuts down. Without these currents moving warm water away from the equator, the tropics reach flesh-melting temperatures, while the poles plunge into deep, permanent freezes. Simultaneously, the global hydrological cycle crashes. Since oceans provide nearly 90% of atmospheric moisture through evaporation, the clouds clear out and precipitation permanently stops. High temperatures and zero humidity quickly turn terrestrial plants to kindling. Dry lightning strikes ignite unstoppable firestorms across the continents, burning whatever vegetation is left. By losing both its heat distribution system and its water cycle, the Earth's atmosphere ceases to be a life support system and becomes a planetary oven. The fires are just the start of an atmospheric collapse. The death of marine phytoplankton instantly cuts Earth's total oxygen production by half. Down in the dry ocean basins, billions of tons of dead marine biomass begin to rot. The massive carbon sink of the ocean floor reverses direction, violently venting toxic carbon dioxide and methane straight into the air. Surface survival is impossible. The last remnants of humanity retreat to deep underground bunkers, relying entirely on hydroponic farms and heavily recycled groundwater. But these localized systems aren't closed loops. Ground temperatures skyrocket, power grids fail without cooling water, and the surface atmosphere becomes thick, hot, and unbreathable. The bunkers eventually suffocate. No amount of engineering can bypass a total biospheric collapse. The loss of the oceans is a terminal event for all complex life. Fast forward 100 years. Surface temperatures blow past 100 degrees Celsius. The planet is a scorched, barren, brownish-yellow wasteland. In geology, void volatile self-lubrication means deep crustal water molecules act like tiny ball bearings, allowing massive tectonic plates to glide. Once this moisture evaporates, lubrication vanishes. Friction spikes. The plates seize up, grinding continental drift to a permanent halt. The only living things left are microscopic extremophile bacteria, huddled in the last few deep subterranean hot springs. Then comes the final blow. Without a cold trap of water vapor in the upper atmosphere, harsh solar winds begin to slowly and methodically strip the remaining air into the void of space. Every major system on Earth, from air currents to the silent drift of the continents, relies on the ocean as its primary mechanical engine. Its absence is the end of our world as a viable habitat. Subscribe to keep exploring the delicate systems that keep us alive.